So we'll be looking at problems from chapter 7. And the first problem we want to take a look at is a simple problem. Again, when we are looking at problems like these problems in chapter 8 are essentially applications of time value of money in the context of projects. So we want to use the same kind of technique that we used in solving time value of money problem. And the technique is to identify the cash flows on a timeline and then transfer that information into your calculator and be able to solve it using that process. So over here, the problem states that your storage firm has been offered $100,000 in 1 year to store some goods, and your costs are $95,000 payable immediately, and the cost of capital is 8%. Should you take this contract? So in terms of a timeline, you have $100,000 that would be payable, that will be paid a year from now. And that's a year from now. And today, you have an upfront cost of $95,000. So that's your benefit, and this is your cost. $95,000 is your cost. So essentially, net present value will be present value of benefits minus present value of costs. So the cost is already in present value terms. So all we have to do is take the present value of this $100,000. So net present value would be minus $95,000, which is your initial cost, plus the benefit, which is the present value of $100,000. That's going to be divided by 1 plus R, or 1.08. So if you do the math, this comes out to negative $2,407. $2,407. Given that this is negative, your answer would be that you are going to reject this proposition or reject this project. Why? Because net present value is negative. The present value of the cost exceeds the present value from any benefits. So very simple application, straightforward application of time value of money concept. Let's take a look at problem number 5. You run a construction firm, you just won a contract to build an office building. The building will require an investment, so this is key. Investment of 10 million today, and then another investment of 5 million a year from now. The government will pay you 20 million 1 year from now. Assume the cost of capital is 10%. What is the net present value? So again, we put this in a timeline. This is a simple 1 period problem again, 1 period. It will require an investment of 10 million. So your one investment today is 10 million. And another investment of 5 million, so that's negative again, 5 million, and the government will pay you 20 million, so plus 20 a year from now. So your net present value would be essentially minus this plus the net of this. Right. So net present value. So your net cash flow a year from now is going to be 15 million. So net present value would be minus 10 in millions. I'm going to not put the 0, just put 10 as 10 million plus the present value of 15 with a cost of capital of 10%. So present value of 15 with a cost of capital of 10. The net is 3.63. So we can calculate this over here, clear everything. Second, clear work. So 15 divided by 1.1, that's 13.63, minus 10, that's 3.63. This is a plus. So in this case, we are going to accept the proposition. Why again? Because we have a plus over here. The present value from the benefits this time exceeds the present value from any cost. Okay. How can you turn this net present value into cash today? You can turn this into cash by essentially borrowing an equivalent amount. The 10 million that you are spending, you could borrow an amount that would be 13.63. So the cash that you would be you would be borrowing in such a manner that the amount that you borrow would mature to 15 million, or the net of this 15 million in a year from now. So this way you can borrow that amount plus 3.63. That will give you. That's the way you can turn this into cash. So essentially the firm can borrow 18.8 million today and pay it back with 10% interest using the 20 million. So it can take the present value of this, it can borrow. The present value of this is 20 divided by 1.1, which is 18.18. So if you borrow 18.18 with a interest rate of 10%, then a year from now, your loan will mature to 20 million, which you will pay off using that loan. And that will leave you with the same net. Okay, question number 7. Question number 7 is a multi-period model. So what we are going to do is we're going to again draw out timelines. If she undertakes the investment, it will pay 4,000 at the end of the next 3 years. It requires an initial investment of 1,000 plus an additional investment of 5,000 at the end of the second year. So, again, we do a timeline. It's a 3-year model. That. So 0, 1, 2, 3. It requires an initial investment of 1,000. So I'm going to put this 1,000 negative. It is followed by a payment of 4,000 each year. And it requires an additional investment of 5,000 at the end of the second year. So there is another $5,000 investment at the end of the second year. So there are 2 ways in which we can do this problem. One is we can net out all the cash flows. So redo a timeline based on the net of all the cash flows. In other words, the new timeline would look like this. So that's year 1 and year 3, those are unchanged. But year 2, the net of 4,000 and negative 5,000 is negative 1,000. So we can take these cash flows and calculate our net present value using the financial calculator. So we clear everything. Clear everything. Go to the cash flow register, click on CF, go to the cash flow register. Do a second clear work, so everything is now clean. So the first cash flow that we have, is negative 1,000. So I'm going to put 1,000. That's in year 0. Change the sign, make sure that's CF0 and enter. Then I do down arrow. C01 is the cash flow in year 1, which is 4,000. Enter. Down arrow. F01 will remain 1. C02 is again negative 1,000. So I have to enter that with the appropriate sign. 1,000, negative, enter. Down arrow. F02 will remain 1. C03 would be 4,000. Enter. And F03 will remain 1. So we have entered all of our cash flows in the calculator. Then I go to net present value. The discount rate over here is 2%. The opportunity cost of capital is 2% as the problem stated over here. So this is 2%. Enter. And then down arrow. And when I see NPV, I'm going to hit the CPT key. Which is 5729. So net present value is 5729. It's positive. So our proposition would be to accept this proposal. Should you take it? The answer would be yes, you should take it. Based on this information, I can also calculate the internal rate of return of the project. It's a simple step. Once I have all the information in there, the IRR key is right next to the NPV key. I click on IRR and the display changes to IRR. And then I click the CPT key. And the IRR is 300%. 300. So IRR of 300. This could be a problem over here because we could have, given these cash flow sequences, we could have a situation over here that there are multiple IRRs. But one of the IRRs would certainly be 300%. And if that's the case, then IRR is greater than R, and we will also accept the project. But one of the reasons we don't use IRR over here, and we rely on the net present value, not the IRR method, because we have these reversal in cash flow. Cash flow goes up, goes down, and then goes up. That reversal causes what we call multiple IRRs. So the IRR, the NPV profile would look like this. So there is 2 IRRs available, and this may be the second IRR. So that 300% may not be exactly the correct answer. So in this case, IRR may not be the appropriate method, and we should only rely on the net present value method to evaluate the acceptability of the project. Okay, let's take a look at problem number 10. So problem number 10, Bill Clinton was paid $10 million to write his book. So this is his cash flow in year 0. The book took 3 years to write, so that's the timeline. But there is an opportunity cost over here. When he was writing this book over these 3 years, he is also giving up speaking fees, and they add up to about $8 million per year. Assume the cost of capital is 10%. What is the NPV? Is it worth agreeing to write this book just on that information? So part A, the timeline would be so 1, 2, 3. He was paid $10 million. So at time 0, he has a positive cash flow of 10 million, but he's also giving up opportunity cost of $8 million each year. So he's losing $8 million. So net present value would be the present value of these cash flows plus the present value of this cash flow. In this case, the future cash flows are negative and the present cash flow is positive. So one of the ways in which we can do this, I'll show you two methods of using the financial calculator to solve a problem like this. Clear everything. Second, clear work. Go into the cash flow key. Second, clear work. So 10 million, 10 represents my cash flow today. CF0 is 10. Then I go down. C01 is 8, but so is C02, so is C03. So C01 is 8, but it's negative. It's 8, negative, enter. Now this cash flow of 8 repeats a total of 3 times, 1, 2, 3. So the frequency of occurrence of this cash flow is 1, 2, 3. It is a frequency, meaning it occurs 3 times consecutively over the timeline. That information I put under the F01. I scroll down using this down arrow, scroll down, and where it says F01, now I should enter 3, not 1. The default is 1, now I enter 3, now I enter all of these cash flows. I can go to NPV, assume a cost of capital of 10%, enter, down arrow, I compute net present value. It is 9.8 million. So net present value is negative 9.89. So negative. So the answer would be, this is not a good proposition. This is not a good idea for Bill Clinton. Just based on that information, it's not a good idea to write this book based on those terms. Now in part B, there is additional information. And the additional information is that once the book is finished, so after 3 years, once the book is finished, it will generate royalties. And those royalties will be 5 million for the first year, and then these royalties, so 5 million for the first year, and then these royalties decrease, not increase, decrease at the rate of 30% into perpetuity. What will be the new net present value? Based on that information, can this be reevaluated? So initially it was negative. So now what we have to do is we have to overlay into our cash flows what happens after year 3. So year 4, year 5, all the way dot, 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 all the way till infinity. So what happens in year 4? In year 4, 5 million is generated from royalties. So the cash flow in year 4 is positive plus 5. But then in year 5, that cash flow goes down by 3%. So it's 5 million times 1 minus 0.03. So the growth rate in this case is negative 3%. Not negative, sorry, negative 30%. So this is going to be negative 30. This would be also negative 30. Okay. So 5 times 0.7. And this will continue. So in year 6, it'll go down from whatever this number is, go down further. So that means the cash flows in blue represent what? They represent a perpetuity because they happen forever, but this is a growing perpetuity, but in this case the growth rate is actually negative. It is a negative growth perpetuity. So for a problem like this, the first thing we do is we calculate the terminal value. What will be the value of all of these cash flows, this growing perpetuity? And we know it's going to be cash flow in year 4 divided by R minus G. So this cash flow divided by R minus G. So it's going to be 5 divided by R, which is 0.1, and G is negative 0.3. So negative 0.3 will become positive 0.3 here. Negative, and this negative will make it positive. So that's 5 divided by 0.13. 5 divided by 0.4, that's 12. That makes it 12.5. So the present value of this entire growing perpetuity is 12.5. So that 12.5 would be reflected here. 12.5 million. Now, the new present value would be, we'll go back to the cash flow. Second, clear work. We clear everything. Second, clear work. Okay, we clear everything. So 10, enter. Now we have 8, but for 2 years. Negative 8. So 8, negative, enter. But this time it occurs only 2 times, because this one will be netted out in year 3. So F02 would be 2 now. F02 is 2 because it occurs 2 times. Then then we go down. So C02 is going to be the net. Although the cash flow says, the calculator says C02, in reality it is the third cash flow. That's a little bit quirky with the calculator. So keep that in mind. That's why timelines make it very clear. So cash flow in year 3 is the net of 12.5 and negative 8. So that will make it positive 4.5. So that's going to be 4.5 positive, enter. And that F02 will remain 1. So we go back. All the cash flows have been entered. Then I click net present value. My discount rate is 10, enter. Down arrow. Compute net present value. It's going to be negative 0.503, or net present value would be negative 503,400 approximately. So even with royalty payment, it remains a net present value and the net present value remains negative. So our verdict would be, if only on pure economic terms, this proposition should be rejected. So because even with including royalties, the net present value remains negative. So this is a little bit of a complicated problem. It's a two-step problem. It includes a series of cash flow upfront that is like an annuity, followed by a series of cash flow later on that is like a growing perpetuity, but with a negative growth rate. I mentioned earlier that this problem, particularly part A, can be solved differently without using the cash flow keys. Just want to quickly show it to you how you can do it. Do a second clear TVM. So for part A, these $8 million cash flow represents an annuity. So those 8 are payment. 8, negative, payment. Present value is 10. 10. Present value is 10. 3. 3 is N. N is 3. Present value is not 10, sorry. Cash flow 0 is 10. So the way we do this, the second method of doing this, I'm going to clear this again. It's clear TBM, clear everything. So N is 3, 8 negative is my payment, right? And IY is 10. So now I can compute present value. That's 19.89, right? Present value is 19.89, and that minus, that would be negative. This present value would be negative, right? So that, because all these cash flows are negative, so negative 19.89 plus 10, that gives you negative 9.89. So you get approximately the same answer. But it is better to use the cash flow key than the time value register to do this problem. Let's take a look at problem number 17. Problem 17. We have a deal that pays up for an upfront payment of 50,000. So that's year 0 cash flow. And then her rate would be 550, 8 hours each month, and cost of capital is 15% for the year. What does the IRR rule advise about this opportunity, and what does the NPV rule say? So again, we have to put together a timeline. She has an upfront payment of 50,000. Then her monthly time, the rate times 8 hours, so 550 times 8, that's $4,400. That's her retainer hours. That is the billable hours that she's billing. So for the upfront cost, she is going to be essentially providing $4,400 of work every month. So that will be essentially negative 4,400, negative 4,400, all the way for the next 12 months. So what is the IRR of this opportunity? So here we have, again, an annuity and then an upfront cash flow. So to solve for the IRR, we are going to use the financial calculator method, clear everything, go into the cash flow register, second, clear work. Our upfront cost, CF0 is 50,000, that's positive. Enter. Down arrow. C01 is going to be negative 4400, negative, enter. And then F01, this $4,400 cash flow repeats how many times? 12 times. So 12, enter. Then I can go into enter all of the cash flows. I go to my IRR key and I say compute. And IRR is 0.84, 8484. That's our IRR. But this IRR is a monthly number. I have to convert this into a yearly number. So I can convert this 0.8484, which is what I get over here. I multiply that by 12, and that's 10.18. So on an annual basis, or annualized IRR, if I multiply that by 12, is going to be 10.18. That's one way to do it. Another way to do it is to use the time value concepts, which is 1 plus 0.008484, right? Because 8484 is in percentage. So 1 plus the monthly rate, I will raise that to the power 12, and I'll subtract 1 from it. And that gives me my equivalent annual rate, equivalent annual rate. So if I do that, so it'll be 1.008484. I raise that to the power y 12 times. Clear everything first. 1.008484 y to the power x. I raise it to the power 12. So that's 1.1067. So that's 10 point. 1. 1.1067 minus 1, so that's 0.1067 or 10.67. So this is more accurate, but this is approximate. 10.18 is approximate, 10.67 is more accurate. In any case, the internal rate of return is less than the required opportunity cost of capital. Since the internal rate of return is less than the opportunity cost of capital, this opportunity is, in this case, we are going to be accepting it. Now, here is the key. Typically, when IRR is less than R, our decision is to reject. But this holds true if the cash flow is a normal cash flow, which is negative first, followed by positive later. But in this case, as you can see, it's positive first, followed by negative later. So upfront positive, followed by negative later. So in this case, if IRR is less than R, this is RR, that 15% represents our R. In this case, we would accept the proposition because the benefit of 50,000 exceeds the present value of the cost of 4,400 for the next 12 months. So we would accept it. We can get the same answer if I look at the net present value of this project. I clear everything. Everything is still entered in my cash flow register. All I need to do is go to my net present value, enter that as 15, enter, down arrow, and I compute. If I compute net present value is 26,149. So net present value is 26,149. It's positive, so we accept it. So we accept the idea, accept the project. And that's problem number 17. And so we will stop over here for the problems in chapter 8.